Number 8, reduced row echelon form. Number 12, you guys have been looking at this for a while, right? 3 by 4. Number 20, we were just supposed to write the the augmented matrix. Sorry, doubly augmented we'll learn today. That's it. Number 8. No, sorry. I don't even know if I got to 8. Number 36. You're filling in a blank, and the blank should have been a -4. Some of you might have been a little confused. But look, they were just establishing the 1, and to establish the 1, you can multiply everybody by -1/3. So 12 times -1/3. Number 46. Row echelon form. Why is it not reduced row echelon form? Pourquoi? How come? Because of what, Nathan? Yep. There's at least one number above the main diagonal. Yeah, so not reduced, but it is in row echelon. Number 78. Take your system, put it in an augmented matrix. I already had the 1, get the 0. Wait a minute. What do we always do when we get a row of zeros? Oh, come on. Let Z equal A, but there is no Z, so who is supposed to come out of this row? A Y. So we let Y equal A. Then plug it in, because it's like the let Z equals A from last chapter. But it wasn't a Z, it was a Y. So let Y equal A. Number 102, ugh. You were supposed to translate what they said. I think they were investing money. It looks like an investment. Either that or borrowing money. Maybe they were borrowing money? Something. We'll say borrowing. Is it a zoo? I forget. Long story short, borrowing money. You guys should have this because you were supposed to write something down from the problem, even if it wasn't the paragraph. Long story short, they borrowed 3 different amounts. Totaling up, they needed $2 million total. They had to borrow at different percentage rates. And I think the interest they were paying was $186,000. Kind of spitballing here, just trying to remember what it was. And something to do with the amount at Z. No, the amount of X was double the amount of Z, and they moved that 2Z over to make a 0. They were able to make a system from that system. They were able to figure out X is 1.2 million. Y is 200,000. Z is 600,000. The 3 different amounts they borrowed at the 3 different percentage rates. They went ahead and went to row echelon form and had to back substitute. You could have gotten to reduced row echelon form. You could have kept going and had the final answers just waiting for you. But to each his own. That's section 8.1. Section 8.2, let's go. Section 8.2, let's go. This one, not as many word problems, right? I don't think so. At least maybe not as long of a word problem. Number 4 should have been the term identity. Number 8. Will you just solve? Oh, this was the one where you had to fill in the terms. X equals -4, Y equals 9. Number 32 is really tiny. Hold on. You guys probably can't see that, huh? Although you're young, you have good eyes, right? Just kidding, you're on your phones all the time. Anyway. Oh, snap. But now they have that whole turn yellow thing when it gets past a certain time. That helps, right? What's it called? The, like, nighttime, the night mode? What's it called? Yeah, that one. It's supposed to be easier on the eyes instead of the cold white. Long story short, number 32. Solve. Here's the final answer. It could have been 1/3 on the outside with -8,2, 8,0 for -18, or you might have brought the 1/3 in. I would have been fine either way. Which one? Because you solve your little baby equation, like add the 4a, divide by 3, or times 1/3. Then you have to, like, do all the different operations with matrices. So either one's okay. I'll take them both. Number 44 is already nice and zoomed in. Matrix multiplication. Question, what made number 44 possible?
No, it's
Okay. What made it possible for, I was like, what? What made it possible for the calculator to solve it?
3 by 3.
The 3 by 3, and the 3 rows will match with the, sorry, the 3 columns technically. Will match with the 3 rows, right? I can do my 1, 1, 2, 2, 3, 3. What if I cut off part of this matrix? What would the calculator have said?
Error.
Yeah, error, not possible, wrong dimensions. But number 44, plug and chug. Number 62. Ooh.
I thought it was not possible.
It actually was possible, and here's the reason why. In order to solve the equation, this was like the last thing we saw yesterday, I think. Take all the coefficients, the variables, the numbers. If we augment the coefficients with the constants, we can use our, what are those again when you see R's being added? Row operations. And if you RREF the entire thing, you end up with 2 3/2 and 3/2. 2 3/2 and 3/2. Is that our last even? Yep. Okay, any quick questions on section 8.1 or 8.2? Caleb, tell me the section and then the number.
Could you go back to section 2, 49? I didn't get the
49?
Yeah.
Okay.
I thought that one.
Okay, any other ones from section 8.1 or 8.2? Calc chat didn't help. Checking the even right now didn't help. Slater didn't help. Friends didn't help. Wolfram didn't help. Are they making fun of you because of their homework?
No, he
From
said
either
he
section?
saved me a donut hole and then he ate them all.
How?
No, the ones he had.
Can I get my spiral?
Yes, you may.
No, I don't want it.
If it's too bad, I'll go ahead and just not let anybody have the other thing. Or I'll get a little baby knife and I'll cut it into.
I like that idea.
It can be donut bites. I see a question. I'm getting the H2 exercises. Naomi, do you have another one?
I had a question because for number 44,
Okay.
I got the first 2 like numbers wrong, but then the rest they were the same.
Oh, weird. 44.
Yeah.
Do you still have the matrices in your calculator, you think?
No.
I bet it was just inputting something like forgetting a negative or putting a number in wrong. That's usually what happens. So if I were you, you could try it one more time and make sure it matches. Let me know if it doesn't. Double check that you wrote the problem down right. That's always a dilemma too.
I have 7 friends.
Alright.
Your brother's a jerk.
Yeah.
Number 49. What were the directions? A times B, B times A squared. A times B, B times A, and A squared. So let's check it out real fast. Caleb, was your question on all 3 parts?
No, I just didn't know. I thought it was not a thing you could do.
Oh, why can't you do it?
You can do it. I put the order in off.
Oh, okay. So if you have a 2 by 2, do the rows, or should I say do the columns? I can't even write. It's been too long since I've been up here. It's legal, right?
Yeah. I said 49. I meant 44.
Doesn't matter.
Did you figure it out though?
Yeah.
Oh, sorry. Guys, why is it legal to find A times B and B times A for these 2 matrices though while we're here?
Because they're both square matrices.
Yeah, whichever way you put it, the insides are going to match, so we're able to do it. Now question, will the products be the same? Check out your homework if you still have it. Were the products the same? No. It still was possible, but they're not the same. How are we supposed to do A squared again?
A times A.
A times A. Was that legal in this one? Do I need to go back and show you? Wasn't it a 2 by 2? I lost it. And you guys lost it because you're all talking and ignoring me. Cool. All right, notes open. We have a lot to do today. I'm going to try my iPad one more time, but if it's not working, we'll have to do the old-fashioned way. It's kind of sad because all of our notes from chapter 8 are in the iPad, not in this file. Restarted everything. Nothing. Nothing at all. Alright, you guys are ready? I know. We're super excited. I might be teaching at the front of the room again. So much cause for conversation, but we gotta cut it off.
Beginning of the year, were you out there?
Shut up, Nathan. Nobody wants to hear from you.
The saltiness, the bitterness, just leave it in.
He started it.
Look, Ricky, you're so
Love thy enemy. That's what it is right now.
Wait, what did I do, Ricky?
You ate my
No
donut.
rubbing it in, no rubbing it
You
in, no rubbing it in.
consumed his donut bowl.
Nathan knows. He had a little smirk. Okay. Here we go.
I'm gonna kill you. He's rubbing
What
it in.
happened to love thy enemy?
You're already showing me
Turn the other cheek.
Can I turn his cheek?
Yeah, feed him more donuts.
He's showing me like the empty cup.
Christ loved those who crucified him. We can deal with donut holes.
Crucify him?
Was that the moral of that conversation?
Yes.
I think it might be.
That's what I got from it.
Okay, if I was to give you the following things from Algebra 1, don't make a mistake. If I was to give you the following from Algebra 1, could you guys solve it?
You know, I think so.
Maybe not Algebra 1, this might be Algebra 2.
No, I think so.
What is the key? What is the compare and contrast? Compare all three. What is in common with all three of those problems? You're solving for it,
It's just X.
but what else is in common? How do you get to x?
You just have to do like a step.
Inverse.
You have to use an inverse operation, an inverse function. You have to somehow undo what is being done to x. True?
Mhm.
Okay. So how do we undo a cube root?
Raised to the power of 3.
Raise both sides to the power of 3, right? And with pretty quick algebraic manipulation,
343.
almost. 343 minus 1.
342. Wait, what?
If we multiply, right? Because 7 times 7 is 49, 49 times 7 is 3 and 6. Oh.
No, it's
Is it 340?
340 minus 1. It's 342.
I was wondering why it's at 320. What are you guys doing out there?
He
Nothing.
threw some paper at me.
That's his brother.
I will say.
Lauren.
I will say that was
No,
amazing job.
no, please.
I hope it is.
Only
Oh,
went a little further.
Let's see what it says.
No mas.
342.
Oh, I'm just reading
There's something on it.
Is
I
that
don't know what it says.
Oh, no.
I think it's salty.
Wow.
It's what it is.
It was the juice. Do you like me? Check yes.
Can you not read that?
You can't even read your hand. Oh, now I do. Depends on how. I thought that was a. He basically is still upset about the donut. Lord has given you grace to rise above.
Okay, I could have cursed. I didn't curse.
Thank you for not We're not supposed to celebrate mediocrity. All right, coming back. It's taping. You shouldn't read it out loud. All right, so it's time to go against some privacy law. Question: how do we undo? I wrote it right now, right? So it's 343 minus 1. How do I undo ln?
E to the power of
Divide by ln. Whoa, whoa, whoa! It's like dividing by a root. That's impossible.
No, E to the power.
E to the power of. Come on, cool kids. We know how to undo ln.
I just
E to the power of ln. What happens?
ln cancels.
And I end up with.
1 equals 0.368.
Why am I putting 1 over e? Ooh, that's algebra 1. When I have a negative exponent, what happens to my expression? Reciprocal. So instead of e over 1 to the negative 1, it's 1 over e to the positive 1. Long story short, at the end of the day, subtract 1 and divide by 3, I end up with
0.211.
1 minus e all over 3. So if I subtract 1, make a common denominator, it would be 1 minus e over e, and then I divide by 3, so it would be over 3e. Ooh, 3e. Close enough. Okay, number 3, how do we undo to get to x? Sine inverse. I have to take the inverse of sine. The inverse of sine. Which, from the unit circle, any cool kids already there? 1 is sine 1/2 in between negative 90 and 90 in between negative pi over 2 and pi over 2.
30 degrees. Yes, 30 degrees.
30 degrees.
I get
Or pi over 6. Done, love that. So, algebraic functions, transcendental functions, trigonometric functions can all be undone with inverses. What can undo a matrix multiplication? It's inverse. It's inverse. However, we do have a few dilemmas, like not all matrices have inverses, which will be a struggle. However, square matrices may have. Did I say do have or may have? May have, so not even all square matrices work. But long story short, in order for a function, just kidding, I'm back to matrices. In order for a matrix to have an inverse, the multiplication of an original by its inverse has to reduce down to the identity however you multiply. That's the little formula you guys are writing. So if we need to check if a function, if we have to check if a matrix is an inverse of another matrix, we just multiply and say, hey, is there an identity left? But in order for that to work, we do, once again, have to only be working with square matrices. So if this is the definition of what it means to be an inverse multiplied by a matrix, it goes down to the identity. Once again, any non-square matrix will not have an inverse. So, what did I just say? If we need to show that one's the inverse of the other, we multiply. So, multiply a times b, multiply b times a. Actually, pause. Right here. This half of the room. Multiply a times b. This half of the room. Multiply b times a. We can do that because they're 2 by 2s. And let's see if they both get the identity. Once again, this half of the room. A times b. That half of the room. B times a. I'll do both. A times b side, do you agree?
I'm not even done.
Well, then finish first.
Well, now you got it.
Well, that's no fun. B times a, I'm going to write the... There, that's nice. B times a side, do you agree? I wrote b next to a because remember we have to go across the b down the a for the b times a side. For the a times b side, it was already set up. Going across the a and down the b. So, what's our conclusion? Yep. B is a. B is a inverse. Yeah?
Is A B B inverse?
Yes, technically, if you wanted to write it that way. The only reason I wrote it that way with B being A inverse is because it said show that B is the inverse of A. But yes, we could say it similarly, since B times A and A times B, we could say A is B inverse. They are inverses of each other. Doesn't that make sense with algebra? Squares and square roots, you square root the squares to undo, but you also square root, you square root the squares to undo, and then you square the square roots to undo. There we go. It goes both ways. Okay, couple terms, real quick. Invertible. What do you guys see in invertible? Yeah, right, it's there. So if a matrix is invertible, what does that mean? It describes a matrix that has an existing inverse. Invertible describes a matrix that has an inverse, as opposed to singular. We'll come back to non-singular in a second. As opposed to singular describes a matrix that is not invertible. I could just say a matrix that's not invertible. Another way of saying it has no existing inverse. Its inverse does not exist. So invertible, the matrix does have an inverse that can be found. Singular, the matrix does not have an existing inverse. Hence, going back up, well then if it's not singular, it must be invertible. So that's why there's this extra term, non-singular. Singular does not have an inverse, non-singular, well, it must have an inverse. And this was the note that I was talking about earlier. Any non-square matrix will always be singular. Non-square matrices cannot have an inverse, therefore non-square matrices are always singular. So if they give you a non-square matrix and say find the inverse, you're going to say, no, not today, it's not possible. Good try. Couple vocab terms. Are we good? Are we ready? Oh, couple more moments. Now guys, basically the rest of today, we might cover a couple applications. The rest of today is pretty much how do you find inverses. I think we're going to talk about three to four different ways. Let's check out one. Let's check out one. Give you guys a second. It just says one way because we're going to see one. One way is to set up and solve the matrix equation. And how we use this little baby formula to help us, we can say A times somebody, and that somebody we're trying to find, you can give an A inverse, equals the right identity matrix, and the right one was a 2 by 2 because of the order of A. So matrix A times somebody, times some matrix, is the identity. But which one? Well, what do we do when we don't know what's going on? And I shouldn't answer. I shouldn't have asked that.
Give up.
What do we do?
Sheep.
Good answer.
No grit. Okay, what do we do in math when we have an unknown? How about that?
Wait 3 minutes.
Yeah, wait 3 minutes and quit because we're not Japanese students.
Maddie, say it louder. We replace them with variables. Come on, beginning of algebra. If we have an unknown, we make variables out of it. We have unknowns, so make variables out of them. A, B, C, D. The book might use like x1, x2, x3, x4, but that gets kind of confusing. Why not just use our ABCDs? We don't know how to do the inverse. If we did, we could do the inverse of the matrix, because you can't divide by matrices. I wish you could. Divide by a matrix? Totally illegal. There is no such thing as matrix division. But what we could do, if we knew it was multiply by the inverse, it'll cancel out multiply by the inverse, we have our answer. But we don't know how to find inverses. So what else can we do?
Multiply.
Cross down. Matrix multiplication. Matrix multiplication. So you guys start doing cross down, cross over down. Cross down, cross over down. 1 times A is A, plus 4 times C is, whatever, 4C. Remember? First times first, 1 times A, plus second times second, 4 times C. Let's cross down, now let's cross over down. 1 times B is B, 4 times D is? How are you guys doing in multiplying? Remember, cross down. Take a row, take a column. First with first plus, times second with second. Multiply the firsts, plus multiply the seconds. Kind of like a little dot product. Using a row and a column, then go across. Row with column. 1 times B plus 4 times C. Time for second row. First times first, negative 1 times A, negative A, plus second times second, negative 3C. Cross over down. First times first, negative B, plus second times second, negative 3B. Now, if that was confusing to you, first of all, you might not like having variables instead of numbers. But second of all, you might not have gotten good at matrix multiplication in section 8.2. So you might need to go back and keep working on 8.2. Ask yourself the question, did I fully do that homework and did I fully understand that? That might be the answer. Now what? You can find the inverse. We want to find A, B, C, D. Beware the notes that are not mathematical. Question. Aren't equal matrices only equal if the corresponding entries are equal? What corresponding entries do you guys see? What does A plus 4C have to be?
1.
Has to be 1. How about negative A minus 3C? What does that have to equal? 0. Do we have a couple other ones?
Yeah.
Okay. What's B plus 4D have to equal? And what's negative B minus 3D have to equal? 1, right? How do we keep going? Simple system of equations. And I think it's easiest to do substitution, elimination, row echelon form matrices. What do you think? Elimination. Look, it's ready. Who's going to cancel? The A with the negative A, right? So we end up with C is equal to? Add them. Can I do elimination on the second one? Sure, why not? Okay. Don't the B's cancel? 4D minus 3D, isn't that just 1D equals 1? That's easy. Who else do we need to find? Yeah, find A and B by plugging in into who? I don't care. One of the ones with an A in it and a C in it. If we plug into here, A minus 3 times 1, A minus 3, A is going to end up equaling pretty quickly. Hopefully you guys found it. Plugging in D. Ooh, it's negative A, isn't it? That's gross. So you plug into the top one. I forgot the negative. Never mind. Let's plug in here. A plus 4, subtract, A equals, my apologies, negative 3. You guys find my mistake? I have to see the negative sign. Then the second set of equations, plug into the top one because these are all positive. B plus 4 times 1. B plus 4 is 0. So B equals, got it. Done! Not exactly. But what can we say once we have these numbers in solver? Fill it in, fill it in. Right? Don't you have an A, B, C, D up above? Isn't there a matrix I'm trying to find? Nope. Honest answers only. A is who? Negative 3. B is who? Negative 4. C is who?
1.
D is who? Done, done. Now, just a few of you were like, wait a minute. This looks vaguely like the original, but kind of rearranged with different signs. You might have a point. Looks vaguely like the original, but with different signs. And that's not always true, but sometimes that happens. Sometimes that happens. How could I check? Yeah. I would multiply A times A inverse or A inverse times A, and we should know, without even doing it, what should happen if we got it right. It's going to be an identity of a 2 by 2, technically. We only have to write a 2. Oh, something's hiding. Who's that? Oh. It's better without hiding. But anyway, long story short, we got the right answer because that times that is that. But we could, if you want to, simplify matters and just say, hey, guess what? Multiply the 2 and we get the identity. Okay, that's one way. But does anybody see a downfall to this way?
Too long.
It's kind of long. It wasn't too bad.
Keep it harder.
If you have more,
What if you had a 3
10
by
by
3?
10.
How many unknown letters would you be missing? A, B, C, D, E, F, G, H, I. Okay, that could be annoying, right? All that multiplication, setting up all those systems of equations. So for a 2 by 2, it's not bad. For something bigger, it'd be a mess. So let's go talk about another way to solve. Messier. But applicable not just for 2 by 2s, but for bigger ones also. It kind of uses the same idea. In that we have A times somebody is the identity. We're using that same definition, kind of an inverse. But instead of assigning A, B, C, D to all these different pieces, we're just going to say, well, let's just cut you out. And let's do the whole augmenting thing, except instead of just being able to take coefficients with like one column matrix, instead of just augmenting it with one column, we're actually going to augment it with the entire identity matrix, which means augmenting with 2 columns. So it looks funny, but it's really a lot like what we did with row-reduced echelon form. The difference is, once again, instead of just having one column because we're only missing 2 quantities, like an x and a y, we're missing 4 quantities, so we're augmenting with the entire 2 by 2 over there. And then the steps tell us how to move on past that. So we take our matrix, we augment it with the identity matrix of the right size, a 2 by 2, a 3 by 3, whatever we need. Row reduce as far as you can. Row reduce, row operations, reduced row echelon form. Good thing we covered it in 8.1. Practiced it a little bit in 8.2. Bless you, bless you. If you are able to fully row reduce and get an identity matrix on the left, which is what we're always trying to do with row reduced echelon form, then on the other side, as we've been doing all those operations to undo this matrix, we have formed on the other side the inverse itself. If you cannot fully row reduce, if something goes like 0, 0, 0 all the way across, the inverse doesn't exist. You can't find it. Couple more moments. Take a matrix, augment it with the corresponding identity, row reduce. So let's see if we can do that. I'll probably give you, I think I have a 2 by 2 on the next page, just to make it easy. But once again, this could work with a 3 by 3, a 4 by 4, whatever size you want. Oh, I gave you a 2 by 2. Oh, go back for just a second. Okay. Ready, set?
Yep.
So what do we do with this guy? Plug into the form, meaning take this matrix, augment it with who? There's nothing there. the identity matrix. 1, 0, 0. And we say, okay, that's all well and good. I see A on the right and the identity on the left. I want to get the identity on the left and the inverse on the right. How? It's time to row reduce, everybody. What's the very first thing we do with row reducing? Work with the first column and get the 1. But there's a 4. How do we get the 1? Multiply following our system, we would multiply row 1 by 1/4. Right? Our system says multiply the top row by 1/4. Could you kind of do a row 1 plus row 2 thing? Yeah. Our system says multiply 1/4. So we would have 4 over 4 is 1. Negative 1 over 4, well there it is. 1 over 4, well there it is. 0 over 4, just 0. And row 2 stays so that. Same. So divide 4 by 4, negative 1 by 4, 1 by 4, 0 by 4. I have my 1. Now what do I get? Now I need a 0. How do I get a 0? According to the system? Multiply the row with the 1 by the opposite coefficient. I'm putting that in row 2. So we'll put that down there. Row 1 stays the same. So as we're undoing this side to an identity, we're also changing that side. So we're kind of morphing little bit by little bit into what we need. Remember, you can do this little equation off to the side if you would like. 3 times 1. 3 times 1 minus 3 is 0. 3 times negative 1/4, negative 3/4 plus 1 is positive 1/4. Going to the third entry, the third column, 3 times 1/4 is 3/4 plus 0. And 3 times 0 is 0 plus 1. Is 1. First column done. Second column's turn. Who do we start with? Get the 1. Right here. So I multiply the second row by 4. Row 1 is going to just chill for a second. What's 4 times 0, starting with the first entry of the second row?
0.
Yeah, 4 times 1/4, 1. 4 times 3/4, 3. 4 times 1, 4. That wasn't bad. So I'm looking, remember, I'm looking to the step before performing my operations. And once again, if you're like, I'm lost. What section was this? 8.1. We did 2 to 3 days. Notes, examples, homework, go back and check it out. First column is done, second column has the 1. All that's left to do is get the 0. When you get the 0, the system says, take the row with the 1, multiply by the opposite coefficient we're trying to get rid of. 1/4, row 2 plus row 1 into row 1. Row 2 is great. What's 1/4 times 0 plus 1? 1. Uh-oh, did I make a mistake?
No. Can I give it back?
Yes. If I do 1/4 times, come back, 1/4 times 1 plus, or I should say minus 1/4, 0. 1/4 times 3, 3/4 plus 1/4, 4/4. 1/4 times 4, 1. 1 plus 0. We undid matrix A, and in doing so, with the doubly augmented identity matrix, can't we say who A inverse is now? Who's left on that side? The matrix 1, 1, 3, 4. Dun, dun, dun. So we use our old skill from section 8.1 in order to find our new unknown of what's his inverse. And since we were able to do it, since we were able to get an identity matrix on the left-hand side, then the inverse exists. And it is who we see. Now hold on, once again, Doesn't it look kind of like a rearrangement of the numbers with some different signs? Okay, hold on. Can you guys see a pattern here? Did everybody flip signs? Who did flip signs? The opposite diagonal flip signs? What did the main do? Huh. So the main flipped and the opposite became opposite. Let's go back to the other one that we solved. What happened to the inverse? The main flipped and the opposite became opposite. Maybe that's a pattern? And the answer is kind of yes. Way number 3. Third and final.
So, is that with 2 by 2?
This last shortcut is sadly only good for 2 by 2s. So hence we didn't cover him first, because it's a shortcut for only.
So we don't need to do, so we don't really need to do any work when we're trying to find the inverse of the 2 by 2?
Almost. If you guys notice, the main does flip, and the opposite diagonal becomes opposite. The problem is, the two examples that we saw, this expression ended up equaling 1, so it wasn't changed any more than that. But not all matrices have this equaling a 1. Here's what's going on with that little expression in front. A times D, we could say, is the main diagonal multiplied by itself minus the opposite diagonal multiplied by itself. We're actually going to learn more about determinants in the next section. This is just a little baby intro. And it is a nice little trick that can be used, sadly though, with only what kind of matrix? Yeah. So we covered the other two with 2 by 2s just because it's the shortest, easiest examples to do. But they work for 3 by 3s, 4 by 4s. This shortcut you can use with 2 by 2s, but don't worry, determinants will do more deep work. Homework. See you tomorrow. That was the last one. And we'll see if you guys figure out how to use the formula tomorrow as well.
Are you kidding me? I don't even get. Screw you, Nathan.
Oh!
That's what was on the
What's
note.
the derogatory? Yeah, that was what was on the note. Hang up your language.
I was like, I was talking.
Naomi, what problem was it? Do you remember?
Something we won't wait for years.
8.2, number 44?
Yeah, 44. Because all the other numbers are.
11, negative 12.
Dude, I failed my calculator. Why are 4?
No.
Oh, I see what I did. I saw.
Oh, because it's the G.
Yeah.
Ah, there you go. All better. You're like, my calculator's broken.
Thank you.
Don't worry, kid. We got it.
Yeah, give it to me later.